يعطيكم العافية طلاب الأعزاء. معكم الأستاذ جهاد خليل، أستاذ مادة الفيزياء بثانوية حسين المكتبة الرسمية. إن شاء الله تكونوا بخير، وإن شاء الله بنرجع على صفوفنا بخير وعافية يا رب. رح بلش أنا وياكم شابتر 1 ميكانيكال إنرجي. أول فكرة رح نشرحها هي work done by a constant force. You know that forces cause motion. In grade 10 we talk about forces like weight, friction, tension, normal reaction of support. Some forces cause object to move. These forces that cause object to move perform work. So if a force F make an object to move, it perform work. So to calculate the work done by a force, we multiply the force times the distance. If an object moves a distance d and a force of magnitude f, the work done by the force equal f times d. إذا أول رول بدنا نحفظها هي ال work done by a force equal الفورس ضرب الديستانس. ال SI unit للفورس هي نيوتن والديستانس المتر. هلا في فورسز بيكونوا بنفس الدايركشن تاع الموشن او displacement بسميهم موتيف فورس، او اللي بيعملوا شيء اسمه موتيف ورك، يعني بيساعدوا الموشن. في فورسز بيكونوا بعكس الموشن، هؤلاء بيكون اسمهم resistive force وبيعملوا شيء اسمه resistive work. أول فورس رح نتعلمها هي الفريكشن، work done by friction force. بنعرف نحن الفريكشن حطول من نرسمها opposite للموشن، يعني هي resistive force عم تعمل resistive work. work done by friction equal minus Fr times d. Fr يعني الفريكشن والدي distance، فإذا الورك للفريكشن هي minus Fr times distance. ليش minus؟ لأنها بعكس الموشن. وشو بنسميها؟ بنسميها resistive work. هلا normal reaction of support عطول perpendicular على displacement، الورك لإلها equal to 0. فإذا الورك للnormal reaction equal 0 جول لأنها perpendicular على displacement. هلا الورك للويت بننتبه لشغلتين. هل الأوبجكت عم يتحرك على horizontal plane أو horizontal path؟ ساعتها الورك equal 0 لأنه الورك perpendicular على displacement. إذا كان الأوبجكت ماشي على horizontal path الورك للويت 0. هلا إذا الأوبجكت moving downward الورك هي mgh plus mgh، وإذا الأوبجكت عم يطلع طلوع يعني moving upward work بيكون minus mgh. نعرف إذا positive يعني motive work وإذا negative resistive work. هو طالع الويت بيكون مش عم بيساعده على الحركة، عم بيعاكسه بالحركة، يعني عم يعمل resistive work. بينما إذا الأوبجكت نازل الويت بتكون عم بتساعده على الموشن، يعني بتكون motive work.
Starting with kinetic energy. Kinetic energy is the energy of a moving object. Whenever an object is moving, we talk about kinetic energy. Take for instance a car. Once it starts moving, it possesses kinetic energy, and that is given by half mv squared, where m is the mass in kilograms and v is the speed in meters per second. Now, since we might use some different units, different than kilograms and meters per second, it is worth mentioning that if you ever encounter a unit which is kilometer per hour, convert it directly to meters per second by dividing by 3.6. And if the mass is given in grams, divide by 1000 to get kilograms. Sometimes we might have the ton as a unit. We multiply by 1000 to get kilograms. Here is an application about kinetic energy. As usual, take a look, read it, try to solve it, and don't forget, in the fourth session, we're gonna dedicate the whole session just to solve these applications. Now, the second part that we need to know before we move to mechanical energy is the gravitational potential energy. Here it's important to mention that when we say potential, it is anything which is stored within a system, within an object, and this object is capable of doing something due to that energy. Gravitational potential energy is the energy stored in the system due to the gravitational field of Earth in particular, and the position of that object with respect to Earth, or a reference that we choose. Now we need to talk about this a bit. If we go to another planet, we definitely have a gravitational potential energy. However, since in our exercise, we just deal with exercise on Earth, we just focused on Earth. Keep in mind that potential energy is energy that is capable of producing something. What is this something here? It is simply the force which we know as weight. Now this is a bit beyond our chapter and beyond the level of this course so far. But it's important to notice or to mention that gravitational potential energy is the reason behind gravitational force, which we know as weight as well. Take this virtual example in which we have 3 bowling balls placed on the Pisa tower. Throwing the first ball from a certain height produces some work, some motion. So that bowling ball is capable of producing some work. This ball, if I release it, it will definitely move down. And I think you are all considering now that this ball is going to reach lower much faster. Not only that, if I consider this, the highest one, it's going to produce devastating results and very dangerous if you are beneath it. And yes, all of that is due to the height above a pre-chosen reference. Accordingly, in this exercise, we have chosen this reference to be this lowest point. Now, if you want to calculate the GPE, which is the abbreviation of gravitational potential energy, we have to consider 2 cases. If the object is above the reference level, as you can see in the figure here, GPE equals mass times gravity times h. Mass is in kilograms, gravity is in newtons per kilogram, and the height is given in meters. However, if the object is below the reference, as you can see in the figure as well, gravitational potential energy is minus mass times gravity times height. Height is always chosen as a positive value. However, we take into consideration whether the object is above the reference or below the reference. And don't worry, the reference is always given in the text of the exercise. Now, to make sure that you got this point, solve this application and check section 4 in order to check the solution. Now, ending the whole thing, we go to mechanical energy. Mechanical energy is simply the sum of kinetic energy and potential energies. Since we just deal with gravitational potential energy, so I've just written here M equals KE plus GP. So in general, we simply say mechanical energy equals kinetic energy plus potential energy in case we have other forms of potential energies. But the boundaries of our course on this level are simply using kinetic and gravitational potential energies. So why bother with other forms? Now, adding mechanical energy, which is the macroscopic external energy of a system, to the internal energy of the system produces what we call total energy. So this is just an idea that we need to know, because in real life we deal with total energy. If you remember the example of the rocket, or the example of the car, or the example of the bungee jumper, all these examples focus on the term of having mechanical energy and probably some other form of energy. The total energy of a system is the sum of mechanical energy of the system and the internal energy inside it. Atoms moving, molecules interacting. Probably in a car, 2 people are pushing each other. That's also internal. The total energy of a system is always conserved. It's never destroyed and it's never created. It is simply transformed. Okay? That's all concerning this session. I hope you got this idea as well. Don't forget, we need to focus on the equations over here, and you have the applications just to apply and make sure that you have got all the points that we need.